Hi, I'm Bob Wormsley from INSYDIUM, and in this tutorial we're going to look at recreating this Surface Advection scene from our FMX trailer. So here's some Surface Advection going on. This is Mario's scene and it looks stunning, doesn't it? So what we've got here is basically some particles that are stuck to a surface and they're rotating. And that's pretty much it. But we're getting this really nice organic fluid-like motion. And this is all using ExplosiaFX to advect particles, not their position, but their rotation. So let's jump into Cinema 4D and we'll get started. So let's build our scene. First of all, what we need to do is create a shockwave in ExplosiaFX, and that we're going to use that to advect our particles. So we'll go to XParticles menu, let's bring in a new system, and we need to go to the Dynamics tab, and the dynamic object is an ExplosiaFX object, which brings in this kind of domain. All right, so we don't need it to be this tall, as the shockwave is going to be blasting outwards, not upwards, so we can just reduce the size of that a wee bit. I'm just going to get rid of the XParticles logo in our system object, so go to Icon and Viewport and just delete that. Right, so because we're not going to be rendering this explosion, we're just using it to advect particles, it doesn't actually have to be that detailed, and as a result we can increase this voxel size, which means that the simulation is going to be less detailed and will be quicker to simulate. So let's just try it on, say, 5 centimeters. Okay. So there we go, we've got our ExplosiaFX source and we've got this default emitter that the system brings in and it's spitting out particles on the Z-axis direction. So we need to change the orientation of that. So let's go to the emitter, we'll go to the Object tab and we'll change the emitter shape from rectangle to circle. And we're going to change the emitter plane from plus Z to plus Y. So now we have this circle emitter firing the particles upwards. What we can do is we can select ring only, and now the particles are only coming from the circumference of that emitter. And now we want the particles to be jutting out as if they were coming from kind of the normal direction of this spline. So to do that, we need to change the cone angle. So if I just hit this 3D button, it gives you this visual representation of the direction of travel of those particles. And if I change the cone angle, you can see the cone widens out and now the particles are going in that direction. So if we put that at 90 degrees, it'll be flat and we get the particles coming out in this flat plane, which is what we want. Okay, so at the moment they're coming out using rate, so they're just continually being spat out. We just want a shot of particles on the first frame. So let's go to the emitter emission tab and we'll change the emission mode from rate to shot. And now this is going to spit out 1,000 particles on the first frame. We don't need 1,000, let's put that down to, say, I don't know, I'll put 150 for now. We can make adjustments later should we need to. So we've got a shot of those particles. I'm just going to reduce the radius of that a little bit. There's our particles. Now I know our speed isn't going to want to be 150. Let's just lower this to, say, 100 and put a tiny bit of variation. Oops, maybe like 7. There we go. I mean, leave them at full life. Okay, so let's just make these particles a bit easier to see. If we go to the Display tab, we can change the default editor display from dots to circles. Now, circles is a really good display type because what it does, it accurately displays the particle radius, which if we go to the Emission tab, the radius is set to be 3 centimeters, and so we're seeing how big a 3 centimeter radius particle is in our scene. So that's useful. Now what we want to do, I'll just leave it at that for now, because this will demonstrate something in a couple of minutes. So let's leave it at 3 centimeters. So now what we need to do is we need to tell our ExplosiaFX domain that our emitter is the thing carrying fuel, which is what we want to ignite. So to do that, we give it a tag to enable it to communicate with the ExplosiaFX object. So let's go to Tags, XParticles Tags, and an ExplosiaFX source, which goes onto our emitter. Now if I hit play, still nothing will happen. And that's because the emitter is able to communicate with the ExplosiaFX now, but the emitter isn't carrying any fuel data, so there's nothing to burn. So what we need to do is go to the extended data tab of that emitter, and we need to go to the physical data subtab, and we will give it, let's just give it, say, 3 fuel. And now if we hit play, still nothing is happening. Why not? Well, the particle radius at the default 3 is too small to be recognized by the domain when we have this voxel size of 5 centimeters. So if we just increase the particle radius, let's put it up to, say, 12, we should get some results. And there we go. So there we have got our shockwave starting. Now, the display mode in ExplosiaFX, if we go to the ExplosiaFX object and display, by default it's set to this slices. And if we want it to look more detailed, we can increase the amount of, you imagine it being cross-section slices making up this, this graphic. And there's 32. So if we change that to 64, it's much more detailed. And then if we increase our resolution, say 120, now we're seeing a lot more detail in this explosion. But this is going to run much more slowly because the display's having to work out a far more detailed visual. So instead of doing that, I'm going to put the resolution back down to, say, 64. Put the slices down to 32, and you'll see we've got much better feedback. So a display mode that I like to use instead of slices is grid. And what you get, let me just make that emitter invisible. What you get is this kind of grid of small spheres. And if we increase the voxel level of detail, we start to get more and more detail in that grid. And we can go above 100%. If I go to 200%, now we've got a really detailed grid of these spheres. This will probably not run particularly smoothly. So let's put it on 150. Okay, so now we've got a pretty well fast-running scene with our level of detail, and we'll get a good representation of what the explosion is, and it's running really smoothly in the viewport without caching. So that's working nicely. So we've got a basic shockwave. One of the problems here with our shockwave is that we're getting this initial burst of fire. The smoke's kind of remaining static, and then it's lifting upwards. So what do we need to do? What we want is the fuel that has been ignited by the particles to respect this initial speed and velocity of these particles. And we do that by going to the ExplosiaFX tag, and we have this velocity value set to 100%. We can go above 100%. So I'm going to put this up to, say, 300. And now we're going to see this fuel carry on its journey outwards, and some of it straggling behind. But that is much more the kind of shockwave that we're looking for. And that's how you make a basic shockwave. If you wanted to render this, that is the basic setup. Now, there's a couple of things that we can do to make this more interesting. In the emitter, let's randomize some of these values. So we'll give a bit more speed variation. Let's give some radius variation as well. And that's just going to make it a little bit more, a little less uniform. And what else can we do with the shockwave? We could, in the ExplosiaFX simulation tab, I'm going to leave all of these default for now. I don't want to confuse things by changing that. But one thing that we could change is we can add a little bit more vorticity, which is going to, it's a bit think of vorticity a little bit like curly turbulence. And it's just going to give us a little bit more detail in the shockwave. And if we were wanting to render this shockwave in a scene as a fire shockwave, we might want those particles moving a bit more quickly. We could put it up closer to 160, and then it's going to fire out a little bit more quickly. So there we go. That's a very, very basic shockwave. But we're not rendering this shockwave. We're just using it to advect some particles. So let's just put that speed down to, I don't know, let's say 80. Okay. So what is going to happen is we're going to have some particles. And in fact, instead of me talking about it, let's just build it. So I'm going to just make, in fact, I'll deactivate ExplosiaFX. So now what we want to do is create our particles, which are going to, their orientation is going to be advected by that shockwave. So we want them to be static, and we're going to make them static by sticking them to a bit of geometry. So let's bring in a plane. That's going to be our geometry. And I'm going to hit ND to display those lines. And we want a new emitter. So let's go to the emitters sub-tab in our system, and we'll create a new emitter. And in the object tab, we want the emitter shape to be an object, and we're going to drag in our plane. We want to emit from the polygon center, and we want to stick particle to source object, and we want one particle per source element. We're going to get one particle per polygon, and they're going to be stuck, they're not going to move. So if I hit play, you can see we now have those particles. Let me just change those from dots to arrows. Okay, hit play. So what's happened is it has spawned a particle, which is an arrow, from the center of every polygon, and the arrow is pointing in the Z direction, which is the default orientation. Okay, so in the emission mode, what I'm going to do, instead of this being rate, I'm just going to turn it to shot. So now we have this. Now, even though the particles have a speed value, because they are stuck to the source element, they aren't able to move. So this speed value has become irrelevant. I'm just going to put the radius value up to, say, 7, so those arrows are a little bit bigger. Right. So what we want is we want these particles to be pointing in the kind of normal direction, the direction of travel. So the way in which we're going to rotate them in that way is we're going to use particle rotation. So let's go to the extended data tab of our emitter, and we're going to go to use rotation and put that on, and we're going to set the rotation mode to tangential, which means that they'll always be facing in the direction of travel. So if I hit go now, they're pointing upwards. Perfect. So there we go. And if I hit play, nothing happens. They just stay static. Now, if I get a modifier, let's just go to the modifiers, and we'll go to the motion modifiers. Let's say we get a turbulence. Now, we would hope that if we add turbulence, let's whack that strength right up. We've got turbulence happening, we hit play, and that modifier is having absolutely no effect on these particles whatsoever. And that is because in our emitter, we have the particles being stuck to the source object. So even though we've got this force trying to move those particles around, it's being overridden by the fact that they are stuck. So that doesn't work. But what we are able to do is use dynamic objects to move these particles, or to change the orientation of these particles, which is really useful. So we are going to use our ExplosiaFX object as this dynamic object, but we could use a different one. Let's just do an example before we use our shockwave. Let's go to dynamic objects, and we'll bring in a flow field. There we go. So by default, the flow field has got this this directional force field going in the plus Z direction. So if I hit play, let's see what happens. The particles are moved from their initial position to the direction of the flow field. So we're able to change the particle orientation using a dynamic object. And this flow field is just set to default, which is in one direction. If I change it to random, we can see that they move into that random direction, which is interesting. So we can change stuck particles orientations using dynamic objects. So let's just delete that flow field. Instead, what we want to do is use our ExplosiaFX shockwave. If I hit play, nothing happens. Our shockwave is calculating, but it's not doing anything to these particles. So what do we have to do? Well, we need to tell ExplosiaFX to advect any particles. So the way we do that is we go to ExplosiaFX, we go to Advection, and we click on Advect Particles. So now, if I hit play, two things have happened. The particles are moving around the place, and they have turned black. Why? Well, they've moved around the place because in the advection settings, we're advecting the particles using velocity. So basically, these particles are inheriting the velocity from the ExplosiaFX. But we're also passing on all this other data that we don't need. We're passing on smoke data. Let's get rid of that. We don't need any smoke data. We don't need any burn data, any temperature data. We do need velocity. It's also passing on color data. Now, because we aren't solving for color in the ExplosiaFX, look, I haven't got color checked. So there isn't any color information, so it's just turning them black. So let's just take away that color. So now it's only the velocity that is changing our particles. It's not looking quite right yet, but it's beginning to work. So let's do a couple of things. First of all, I think that the explosion is happening a little bit too quickly. So in our emitter source, let's change the speed down to, say, 60. And what I want to do is I want full randomization of that speed. So some of the particles will be going at 0 centimeters per second, and some will be going faster. And this will change that, and it'll mean that we'll continue to get movement near the middle of our shockwave. Okay, so we're getting there. It's still not right yet, but we're kind of getting there. So instead of our shockwave starting from the center of this plane, we want it to start from this edge and spread outwards. So all we need to do to affect that is we need to move the a shockwave emitter from here, and we need to move it to the edge. And now it's going to spread this way. Okay, and now, an interesting thing is happening here, which is messing up our shockwave. If we have a look at our shockwave particles, they're flying all over the place. These are the ones creating the shockwave. And that's because these particles are being advected by the shockwave they're creating, and it's messing up the simulation. So what we need to do is tell our shockwave particles not to be advected, only our arrows we want to be advected. So to do that, we go to the shockwave emitter, we go to the modifiers, and we'll drag in to exclude ExplosiaFX. So now that's better. Now we're getting this spreading out shockwave. And that is going to mean that our shockwave is going to remain as it should. I'll make those particles invisible. Now we've got a shockwave spreading across this plane. Good. So now if we disable the vision of the shockwave and look at our arrows once more. So now we're getting something that is beginning to look like a spreading out. But you can see a very strange things happening. We're getting this very defined square edge where our particles are going from pointing straight upwards as their default position and orientation to being laid flat. Now, why is this happening? Well, if I reveal my ExplosiaFX domain, you're going to get an idea. And it's all to do with this bounding box, which is the bounding box of the simulation calculation. Now, what is happening is, outside of this bounding box, there isn't any different velocity information, because it's not, the ExplosiaFX isn't solving this area. It's only solving what's inside of this bounding box, which means that when this jumps outwards, we're getting this very rigid line, which obviously isn't what we want. So if we want to advect particles in this way with orientation and stuck particles, what we have to do is switch off this adaptive bounding box solving of ExplosiaFX, which means that unfortunately it will be a bit slower to solve. But because we're doing it at such a big voxel size anyway, it's not going to make that much of an impact. So I'm going to switch off adaptive bounds, which means it's going to solve the entire thing. And now we have got something that's working much better. So let's just make that explosion invisible. So let's see, we've got the explosion, and then we've got this spread of our shockwave. Okay. So let's just try and make this look a bit more visually appealing so we can see what's going on a bit better. What I'm going to do is I'm going to make the arrow smaller by going to the emitter, and let's put the radius back down to 4. So now we've got smaller arrows, and I want them to be far more arrows. At the moment it's not densely populated enough. So because this is all procedural, I'm able to just go to the plane, add some more segments. Let's put it up to 80, so it's way more subdivided, but now we're going to get way more particles. And we hit play, and now you can see we're getting this really nice organic spread as these particles are making their way, being orientated by this shockwave advection. So that is looking really nice. And that's the basic principle of how this works. So obviously Mario rendered his scene in Cycles 4D, and we'll move on to do that in a little bit, and I'll show you how he set up his render. But just in case you haven't got Cycles, you can of course just use the standard or physical render to render out a very similar look. So the way we'll do that is we will do it using an X-Particles generator, and we'll just generate some clones. So let's just make the clone first. So we'll bring in a cube, and let's just reduce that down. So we want the cube to be a long thin stick, effectively. So let's just change this. I'm just going to eyeball it. Okay, that's probably still a little bit too wide. Let's put it down to say 3, 3, and like 20 high. So this is what we're going to clone. So now what we're going to go, in the emitter, I'm just going to, let's just hide the visibility of those arrows. So now we're going to go to generators, and I'm going to go to the generator menu, and we're going to pick an XP generator. And this XP generator asks for which emitter do you want to generate geometry to. So let's go to, it's this one, drag it in. And now if I make my cube a child of the generator, and we go forward one, now we have generated all of these cubes. Very nice. Now they're not orientated correctly, because what it always does, it orients them in the plus Z direction. So what we need to do with my cube, let's just pull that out. And so we want it orientated in this way. So the quickest way of doing that, we want the pointy bit going that way. So we want it in the Z, and this will become the height. So let's put that at, what was it, 23 and 3. Let's put that back in my generator. Hit go. And there, that's better. So now they're orientated in the right way. And what I'll do is let's go to generator, and let's make these render instances, and it should move much more quickly. And there we go. And we're getting this spread. That's looking good. And what we could do is obviously make adjustments to this. You can make these fatter, so there isn't as much of the plane. Let's make the plane invisible. So you could have more. You can maybe you'd want to increase. Let's get this plane still parametric. So let's have more clones. This is going to be loads now, but we're generating these on the fly. We're still getting fairly decent feedback. Seeing as our ExplosiaFX sim isn't cached, it's not doing too badly. And there we go. So then, of course, what you can do is make a material, apply the material to your generator, and this can be rendered using standard or physical, and that is going to work as desired. So that's how you do it the old-fashioned way. I'm just going to get rid of that generator. Make the emitter visible again. So I'm back to my arrows. You see with arrows, obviously, we've got much faster playback. So we're going to be using Cycles 4D. So what I'm going to do is I'm just going to jump into my Cycles 4D layout, and we'll go through setting up this scene, lighting it, getting the materials on, and how we'd set up our render settings. So here's my cycles layout, and we've got the object manager here in the top right, attribute manager as normal below in the bottom right, and then this is where it's slightly different. Here's my viewport, which is smaller, and I've got my Cycles 4D real-time preview above it. At the moment, it's just rendering black because we have no lights in the scene. Then I've got a larger area here for my my material node editor. So let's get going with this then. If we go forward one frame, what we want to do is we want to sort out a camera angle and put some lights in the scene, and we're just going to do this as if it was a still. You obviously can render this as an animation and do with it what you like. So what we want to do is get a decent camera angle. Now, it's quite difficult to see how our simulation is working at the moment because we've got this display mode, these arrows that are only outlines, and they all kind of merge into one big blob, and we can't see any individual kind of patterns developing as they rotate. So what we can do, a really quick trick to be able to sort that out, if we just go to the viewport options, let's go to the OpenGL options and just activate the ambient occlusion, we'll get this fake shadowing, and now we can see the moving a little bit better. It's not perfect, but you can get the idea of this really nice kind of organic spread. And this, it looks like a very organic kind of growth system, doesn't it? But all it is particles rotating. But it looks really nice. So what we need to do is get a camera angle that we like. So we want to kind of get up close and see some of the kind of patterns moving. Maybe retain some of the flatter areas. So maybe something like this. And obviously you spend an awful lot longer getting the angle that you would like. So that's looking pretty good. So let's just fix that down. We'll go to the Cycles 4D menu and bring in a Cycles camera. And let's just put a Cinema 4D protection tag on there so we can't move it. So now that camera's set. Excellent. Right, now that we've got our ambient occlusion on, we can see something that odd happens on frame 1. If I go forward on frame 1, you can see that, look, every single arrow is orientated, it's looking upwards, so it's kind of on the normal of the plane. Apart from this square in the middle of arrows, which are pointing in the Z direction, which is an error. I mean, that shouldn't be there. Why are we guessing that? Well, this is a bit of a quirk of ExplosiaFX, and there's a very, very quick and easy way to get around this. If I make my exposure visible again, what you'll see is if we go back to frame 0, we suddenly get a small adaptive bounds box. Now, this is despite the fact that in Explosia, in the Solver tab, we switched off the adaptive bounds. But for some reason, kind of a quirk on frame 0, we're getting this adaptive bounds. And the result of that is, if we just make that invisible again, on the following frame, particles that were within it are being advected in their rotation, and we're getting this cube of advected particles, which is wrong. Then we move forward the next frame and it goes correct again and the simulation begins. So it's really easy to get around that actually. What we need to do is go to the ExplosiaFX object, let's go to the Advection tab, and on frame 0, let's deselect advect particles and put a keyframe. Then on frame 1, we will select advect particles with a keyframe, and now, there we go. So that's sorted. Great. Okay, let's go back to our camera. So this is where we're going to be rendering this from. So we're not seeing anything in our real-time preview. That's because we haven't got any lights. So let's bring some lights into the scene, and we're going to use some geometry instead of light. So we're going to give that geometry an emissive material, which means that the geometry will be casting the light. So I'm going to go to my objects menu up here and take a plane, and we'll just rotate that. And I'm just going to eyeball this. As I say, I'm not going to spend an awful lot of time getting this absolutely perfect. Something like that is going to work. I'm going to have it quite low down, because this is going to be providing light in the scene, but mostly we're going to be using this to reflect off our shiny surfaces, which will be replacing our particles. So that's what we want. So there's our geometry. Let's go to create, Cycles 4D surface, and we'll make an emission shader. And I'll just drag this and drop it onto the plane. Let's set our real-time preview rendering, and there is our plane with the emission material on it. But at the moment we can't see the particles. Why not? Well, that is because the particles have no material, so Cycles isn't able to recognize them. So let's go to create, Cycles 4D surface, and what we'll use is the principled shader, which is a fantastic shader because it allows you to do diffuse objects with specular should you wish. You can use this to make metal materials, you can use it to make glass, and you've got fantastic subsurface scattering in there as well. So it's a real kind of can-do material, and it's very versatile. So let's put that principled shader. First of all, we'll stick it on our emitter. And now we can see that we're getting something rendering here. So let's just get that light, and we'll change the color to full white. Actually, let's just slightly off white. And increase the strength a little bit. So now we're seeing, if I dolly in here, we're seeing something being rendered. And what is being rendered is every single particle. We're not getting the arrows. Every single particle, Cycles is instancing a sphere on those particles. So that's what we're seeing. That's not quite what we want. We want to instance some geometry at every particle position. So to do that, we need to go to the emitter in question and go to tags, Cycles 4D tags, and give it an instance tag. Okay, nothing's changed because by default, the instance tag creates spheres. But now if you look in the tag attributes, we can drag in any geometry into this, and it will instance it onto the particle position. So let's get that sorted. We will create, let's just do it with a cube. So we've got a cube, and let's make it thin, and we want it to be tall on the z-axis. And I forget this every time I do it. I'm pretty sure the z-axis will be instanced pointing upwards. So let's just go into this cube and we'll put it down to say 2 centimeters on the X and the Y, and then maybe 15 centimeters on the Z. So quite a small object. And then we'll go to the emitter instance tag, drag in the cube. So there we go. We can see that this is starting to work. And here are our cubes being instanced by this tag. So at the moment, they're just this kind of clay material because you have to actually texture the object for which you are instancing. So if we drag this material off our particles, because we don't want to render those spheres anymore, and pop it on the cube, now we're getting this object. And just to demonstrate that in that principled shader, let's just change the color. I don't know, blue. So there we go. We're getting this blue material on here, and we're getting a bit of reflection off this light, and that's because we have a specular value. We turn the specular off, we're not getting that. Turn that back up. So there we go, and let's just put that back down to near white. Right, so that's good. I think, let's look through our camera. So I think these cubes are still a little bit too big, aren't they? They're intersecting too much, and we're not getting that nice kind of wave pattern that we got in Mario's render. So let's go to our instance tag. Instead of changing the dimensions of the actual object we're referencing, we can just do this size multiplier, when this will just scale it down. So there we go, scaling that down. And now we're getting these. What we could do, I suppose, we could add a little bit of variation as well, just so it's less uniform. And now we have got this. Now the disadvantage of doing the size variation is that we're not getting particularly flat values anywhere in our plane. And it would be quite nice to have some flat values because we'll get some really bright reflections off those sections. So that's, I mean, it's looking quite stylized for an abstract piece. Let's leave it like that for now. So instead of this being a diffuse material, what I'd like is for this to be a metallic material. So all we do with the principled shader to get metallic is to go from metallic 0, put it all the way to 1. And now this is a metallic object, but because there is no roughness at all, the only place where we're able to see this metallic surface is where it's catching the reflections from our lighting plane. But if we just increase this roughness, it'll make it slightly more diffuse, and now we're starting to see other areas of this metal. So that's looking pretty nice. What we could do is, in our emission material, we can change this color. Let's just add a bit of a color value. And be quite subtle with this, goes a long way. And now we're getting this really nice kind of brass, kind of gold looking tint from here. If we were to increase the strength, we can kind of blow these areas out a little bit and get these really harsh highlights. Okay, so that's looking all right. Another thing that we're able to do, if we move the plane, let me just take this camera out. If we move this plane down, we're going to get a much more contrasted look, but we're still going to get a very bright hotspot reflection here. And so the result, if we come back to our camera, we're getting these really bright areas, but we're getting lots more contrast here, which is quite an interesting look. We could also perhaps move this plane over here to again. So now we're getting this really bright area and so much more contrast. So that's working okay for now. Let's just duplicate that light source. So I'm just going to hit Control, drag it here. Now I've got another one. And what I'll do is let's rotate that kind of this way. And this is going to add a little bit of reflections on this side and fill the shadowing area ever so slightly. I'm just going to lift it up a bit as well. Now, what I'm going to want is a different material for my second light here. So what I'll do is I'll control drag this emission material, which makes a new one, put the new one onto our plane 2, which is our second light, and then with this material, let's put the strength down, and we can give it a different color. So we could go to blue. So we're getting this nice blue sheen now on this side, which is nice. And I think we're slightly too overblown here. I think if we had a slightly different camera angle, it might work okay. If we have this camera angle so it's not pointing down as much. So something like that may kind of work okay. But let's just stick with our original for now. Right, so what we'll do, let's just take this original material, reduce that strength down somewhat to bring back some of that nice colour. And let's just saturate it slightly more. Sorry, it's always a good idea to adjust colours from this pull down menu, because you can actually do it in real time and it'll update in front of your eyes. Whereas if you click on this, you can still adjust them, but you won't see the results of that until you press OK. So it's always a good idea to, instead of clicking in here to pick your colour, press the down arrow, and then you can do it in real time and see those changes happen in front of your eyes, like magic. Right. So I think we could perhaps have a little bit more roughness, or make a bit slightly more diffuse material. There we go. So the last thing to make this look stylized is we can go to the camera and we'll go to the Cycles 4D tag, the camera tag, and in the depth of field settings, we can increase the size of this radius. So it's immediately blurring this image out. So it's made a very shallow depth of field. So what we need to do now is tell it which area of the scene we want to be in focus. So to do that, you click on the camera, go to the object tag, and you've got this focus distance. So click that button and you can point anywhere you like in your scene to get to pull into focus the area which you'd like. So let's do this third down here. Increase that radius so it's pushing it all out of focus, and obviously you can pick whichever bit you want. This middle section. All right, so that's working okay. So just finally, what we're able to do here, and we mentioned this in another tutorial, if you're using the early access cycles, we have a new bevel node, which is a rendering bevel node, which means that it does it at render time. So instead of, if you want your cubes to have a nice smooth edge, you could do it in the actual geometry that's being instanced by putting this fillet on. But the problem with that is it's actually making more geometry, and then it's instancing that geometry thousands of times, and it's going to chug and slow you down. So what you're able to do with the bevel node is to make that bevel at render time, which is much quicker. So the way we do it is we right click in our editor, let's go to input, and we've got this new bevel node. And what you do is you drag your normal output into the normal input of your principled shader. And the key here is that the radius is going to have to be really tiny, especially in a small scene like this, probably 0.001 maybe. And it's just a subtle change, but what's that's done is it's added a smooth beveled edge to these cubes, which make it slightly less uniform, and just make it's more pleasing on the eye, because really in the real world, no matter how beautifully and detailed machining of metal is, you're never going to get a perfectly right angled edge. So always putting a bit of bevel on is nice, and then bevel node means that you're able to do that at render time, which is very quick compared to actually producing and creating the geometry in your source object. So there we go. And obviously this isn't samples aren't high enough here. We have got areas of noise, so let's just stick this up to say 30, and it's gradually chugging away, cleaning that up, and you'll see that these areas will get nice and clean the more it goes. You can also use denoising should you wish to try and speed up your renders. Denoising means that you can have fewer samples and it kind of blurs out the noisier areas. You've got to be a bit careful with it because it can make your renders look a bit blurred and a bit blobby, but it can be a very, very useful technique. But we'll have more on rendering and more specific rendering and detailed tutorials on that later. So that's pretty much it. We've taken our ExplosiaFX shockwave, we've used that to advect stuck particles, which means only their rotation is advected, making this really nice wave pattern, and then we've rendered that using Cycles 4D, instancing very simple geometry, beveling that at render time, which saves time as well, and the result is this really nice abstract scene. And as you can see, if you in Mario's example, if you spend a long time animating the camera, getting your lighting spot on, you can get some pretty stunning effects. So as you can see, a relatively simple technique there, which gives some fantastic organic looking results. Don't forget to subscribe to our YouTube channel to get alerts whenever we've got new content published. And also you can find out information about how to get hold of X particles, Cycles 4D, and how our maintenance system works. All that plus loads of free scene files on the INSYDIUM website. So do check it out. Okay, that's it from me. I'll see you next time.